Assalamu alaikum students. Today we will study differential calculus problem set 7.5 from mathematics with application in management and economics written by Pitcher and Saville. So today we will continue problem set 7.5. Today we will study the remaining part of the problem set 7.5 where the question is saying that find the slope of the tangent to each of the following curves at the indicated value of x. So tangent means, the word tangent means when one curve touch another curve, the curve that touches another curve is called the tangent, and the point where the tangent touch another curve is called the point of tangency. That means here the question is asking find the slope of the tangent to each of the following curves. Always remember, a function represents a curve. A function always represents a curve. The curve, it can have any shape. It can be like circle, it can be straight line, it can have any shape. It can be parabola, hyperbola, or circle. It can have any shape. But always remember, a curve can be represented by a function, or a function represent a curve. So the question is asking us to find out the slope of, not the curve, slope of the tangent. But remember, at the point of tangency, where the tangent touch the curve, at the point of tangency, slope of the tangent and also the curve is same. So that means at the point of tangency, slope of the curve and slope of tangent is same. So to find out the slope of tangent at the indicated value of x, we just need to find out the slope of the curve itself. So here the function we have fx is equal to 3. So that means function of x is equal to 3 where x is the variable, So here you can see, that means if you do differentiation, to find out the slope, we need to do differentiation. We need to do differentiation. And always remember, when you do differentiation of a function, we get prime. That means if the function is f(x), then after we do differentiation, we get f prime x. So as I said before, slope, to find out the slope of a curve, we need to do differentiation. If you want to find out the slope of this curve, you need to do differentiation. That means this is the slope function. After you do differentiation. So now as you can see, the variable is x, and we do not have any x here. So obviously differentiation is, answer of the differentiation is slope is 0. That means slope is 0. Right. Since the question was asking us to find out slope at x is equal to 1. That means this is the slope function. This is the value of slope, or you can call it like this is the slope function. Since there is no x here, so function of that means the slope function with value of x equal to 1 will also be 0. That means slope is 0 here. Now let's move to the question number 29. So here also again we need to find the slope of the tangent. To find out the slope of the tangent, we just need to find out the slope of the curve, because as I said before, slope of the tangent is same like the slope of the curve at the point of tangency. So here you need to find out the slope of this function, or slope of this curve. So we already know that this is the function. We need to do differentiation of this one. As you already know by now that if you have something like this, we need to separate each part. So we need to separate each part like this way. Okay. So and if you do differentiation, this 3 is the coefficient. Of x square. We need to move this one out. And if you do differentiation of x square, the power, you need to write the power first. And the existing power will be reduced by 1. So we have the existing power we have is 2. If it is reduced by 1, then we will have only power 1. As I said before, power 1 you may not need to write it. So we will just have x. So that means the differentiation of x square, is 2x. So the differentiation of x square is 2x. Right. So now here again, so here we have variable x and we have 2x there. So if we do differentiation, we will get 2. So that means this is the slope function. So 6x minus 2 is the slope function. This 6x minus 2 is the slope function. Now the question is asking us to find out the slope where the value of x is 0.5. That means we need to find out the slope where the value of x is 0.5, right? So that means we will just put the value of x as 0.5 here. So if you put the value like that, so that means the answer is slope is 1. Slope is 1 when the value of x is 0.5. When the value of x is 0.5, we got the slope is 1. The slope is 1. So that's the answer of this question. So similarly, you can find out, you can solve question number 30, you can solve question number 33, you can solve question number 35, and all these questions. Now I will jump to question number 41. Question number 41. The question number 41 is saying that if the total cost of producing y yards of yardol is a particular product. So if the total cost of producing y yards of yardol is this one, so that means, as you can see, the function is this is as I said before, the function can have different name. The function can have, as I said before, the function can have different name. Here the name of the function is c. Here the name of the function is c, because this is the cost function. That's why we name it like that. We name it like the name of the function is c, where the y is the variable. This is the variable. So this is the cost function. Now the question is asking, find the marginal cost at output of, the first question is asking, you need to find out the marginal cost of output at 1000 years. Then we need to find also the marginal cost at output 2000 years. Now before we go for this one, we need to first understand what is marginal cost. So let me write the definition of marginal cost. Marginal cost is the cost. Marginal cost is the additional cost to produce additional unit. That means marginal cost is the additional cost to produce additional unit. So let me explain it in more details. Suppose the total cost of producing 20 pajamas or 20 trousers. Suppose the total cost of producing 20 trousers. Suppose the total cost of producing 20 trousers is equal to 25,000 taka. Suppose the total cost of producing 20 trousers is 25,000 taka. Then again, total cost of producing 21 trousers. 21 same quality, same kind of trouser is, suppose this is 26,500 taka, right? 26,000, suppose 26,300 taka. So you can see, if you want to produce one more unit of trouser, so if you produce total cost of producing total 20 trouser is 25,000 taka, but if you want to produce one more trouser, then it will cost you additional 1,300 taka. That means this is the marginal cost. That means marginal cost of producing 21th trouser is equal to 26,300 minus 25,000 taka. So which is 1,300 taka. So that means if you want to produce one more unit of trouser, you will need to pay additional 1,300 taka. So this is the marginal cost of producing 21th trouser, okay, or 21st trouser, or 21st trouser. So that's the marginal cost of producing 21st trouser. That means, right, so this is 1,300 taka. So how should you, even if you write it in a formula, if you write it in function, if you write it in formula, if you write a formula of marginal cost, then how should you write it? So you can write this one like, if the total cost function is denoted by C, if the total cost is denoted by C, then this is the total cost of producing 20 units. This is the total cost of producing 20 units. Similarly, if this one can be written as C. This is C is the total cost, and C 21. So this is the total cost of producing 21 units. 21 units of pajama, 21 units of trouser. So now, so how should you write marginal cost? Marginal cost of 21st unit. So that means let us denote marginal cost function as MC. So MC 21, that means marginal cost of producing 21st unit is equal to, it can be written as C 21 minus C 20. So that means it's like this. So that means marginal cost function can be written as, so if you want to find out the marginal cost of 21st unit, that means in that case you need to take total cost of 21 unit minus total cost of producing 20 unit. So similarly, if you want to find out the marginal cost of producing 8th unit, if you want to find out the marginal cost of producing 8th unit, then you need to find out the total cost of, producing 8th unit, you need to find the total cost of producing 8th unit excuse me, minus total cost of producing 7 unit. So if you want to find out the if you want to find out the marginal cost of producing 8th unit, then you need to use this formula. You need to find out the total cost of producing 8 unit minus total cost of producing 7 unit. So similarly again, if you want to find out the marginal cost of producing for example 45th unit, if you want to find out the marginal cost of producing 45th unit, if you want to find out the marginal cost of producing 45th unit, in that case you need to find out the total cost of producing, you need to find out the total cost of producing 45 units, and then you need to deduct total cost of producing 44 units. Total cost of producing 44 unit. So these are the formula to calculate marginal cost, right? Right. So here the question is asking us to find out the marginal cost of produce. First of all, we need to develop a function. So we can, so here the marginal cost of producing, marginal cost can be written as like MC, marginal cost can be written as like MCY that means marginal cost of producing yth unit. So that means marginal cost of producing yth unit can be written as like C y minus C y minus 1. So marginal cost of producing yth unit can be written as total cost of producing y units minus total cost of producing y minus 1 unit. So here in the question it was asking us to find out the marginal cost of producing 1000th unit, marginal cost of producing 1000th unit. So that means we need to do it like that means the formula will be like C 1000, that means total cost of producing 1000 unit minus total cost of producing 999 units, right? So the cost function, this was the cost function, right? So this was the cost function. Here the cost function was like this one. So here the cost function was like this one. So now as you can see, so what will be the value of this one? What will be the value of this one? As you can see here, this is the cost function. This is the cost function. Now if you here instead of y we have 1000. So similarly here also we need to replace the value of y by 1000. So that means 1000 square multiplied by 1000 equal. So that means let us calculate it. So if you use your calculator, type it exactly like the way it is. You can type the full you can type in your calculator from here to here fully, okay, and then equal. If you press equal, 0.001 multiplied by 1000 square plus 2500 excuse me, so 3500. So that's the total cost of producing 1000 unit. That's the total cost of producing 1000 unit. Now let us find out total cost of producing 999 units. Now we need to find out the total cost of producing 999 units. So similarly here what we will do, we will put 999. Here also the value of y is 999. So now let us calculate. So 2 multiplied by 999, 500. So now we got like 3496.001. So 3496.001. So now the marginal cost of 1000th unit. So the marginal cost of producing 1000th unit. So now the marginal cost of producing 1000th unit should be like 3500 minus 3496.01, right? So now 3500 minus this one is $4 is equal to approximately like approximately like $4. 4. So that means that's the answer. That means marginal cost of producing 1000th unit, marginal cost of producing 1000th unit is equal to $4. So that's one way of calculating marginal cost. Similar, but another, in this chapter we are doing differentiation. We are studying differentiation. Using differentiation also we can find out marginal cost. Using differential calculus also we can find out marginal cost. So marginal cost marginal cost of producing yth unit can be written as C prime y. C prime y means, like, if you that's the cost function. This is the cost function. This is the total cost function. This is the total cost function. If you do differentiation of total cost function, you will get marginal cost function. So that means if you do differentiation of total cost function, you will get marginal cost function, which can be denoted as C prime y, because this is the original function, this is the original cost function, and if you do differentiation you will get prime. So that means C prime. So let's do differentiation now. So this is the cost function, this is the cost function, and if you do differentiation you already know how to. So you have a plus there, so you need to separate each part. So and if you do differentiation, what we will get? So here 0.001 is the coefficient. It has to be, you have to move it out, and then you need to do differentiation of y square. If you do differentiation of y square, you get 2y, and if you do differentiation of this one, you will get if you do differentiation of this one, you will get 2. So if you do differentiation of this one, you will get this one, and so that means this is the slope function. This is the slope function or marginal cost function. So this is the slope function or marginal cost function. So marginal cost function is equal to this one. So marginal cost function the marginal cost function C prime y, is equal to point. So this is the marginal cost function. So this is the marginal cost function. After differentiation we got this one. This is the marginal cost function. After differentiation we got this one. Now here the question was asking us to find out marginal cost at 1000 years. So marginal cost at 1000 years, that means the value of y, should be now 1000. So the value of y should be used as 1000. Value of y should be used as 1000. So if you put the value of y there, you will get like, the answer is like $4 per yard. $4 per yard. That means marginal cost of producing 1000th yard is $4 per yard. So similarly, if you put the value of y as 2000, you will get the marginal cost of producing 2000th unit, that is $6 per yard. $6 per yard. So that means if you do differentiation of total cost function, you will get marginal cost function. So that means you can use differential calculus to find out the marginal cost, right? Okay. So you solve question number 40, you solve question number 41, not 41, question number 42. You solve question number 42 at home. This is question number 42. You solve question number 42 at your home. This is the same problem like before. This is the similar problem like before. So you solve it at your home. Now we will move to problem set 7.6. Now we will move to problem set 7.6. Here the first question is asking us to find out the differentiation again. Here let's solve it. Here, so this one is the this one is this. So now, so that means now you need to do the differentiation of 6x minus 5 to the power 5. That means there is a bracket here. There is a bracket here. So when you have something like that, when you see there is a bracket and on top of that power is there, first of all you need to process differentiation of power. First of all you need to process differentiation of power, right? Always remember, power should be handled, power should be processed first. Power should be processed first, because let me use some very easy language or fluid language for you here. Consider it like a suitcase. Consider it like a suitcase. Consider this bracket as a suitcase or a briefcase, and on top of that this is the lock. This is the lock. So that means the briefcase or suitcase, whatever you call, it is locked. It is locked. So if you want to reach the inside materials, of the briefcase or suitcase, you first need to unlock it. This is the lock. That means you need to unlock it. That means you need to process this one first. That means you need to process this one first. So that means you need to process the differentiation of power first. Then only you can do the differentiation of the inside materials, right? So how we do it? First of all, as you already know, the rule of power, if you see there is a power and if you want to do differentiation, always should write the power first. That means if you see that there is a power and you want to do the differentiation, in that case power, you should write the power first, and then you will write whatever you had before. That means you will write exactly like you have, and then from the power you will deduct 1. And from the power you will deduct 1. So this is the rule of exponent. That is, this is the rule of power for differentiation. So that means if you see there is a power, you need to first bring the power. So that means the power, you need to write the power first, and then you will write exactly what you have in your hand, you will write exactly what you have in your hand, and from the power you deduct 1, and from the power you deduct 1. So that's the differentiation of power. That's the differentiation of power. Now you have already processed this one, so that means you have already unlocked it. That means you have already done the differentiation of the power. That means power is done. That. So now you can process inside materials. Now you can process inside materials. So that means now you have to do the differentiation of, now you need to do the differentiation of inside materials. Inside materials, inside what you have? Inside you have 6x minus 5. Inside you have 6x minus 5. So that means, I'm repeating again, first you need to do the differentiation of power, and when you do the differentiation of power, you need to write the power first, and then from the existing power you will deduct 1. You will deduct 1. That means 5 minus 1, and then you will do differentiation of inside materials. You will do differentiation of inside materials. So you need to do differentiation of inside materials. Right, so what do we have? So power 5 minus 1 is equal to 4. Power 5 minus 1 is equal to 4. And if you do differentiation of this one, as you can see, we have 6x here. So if you do differentiation of this one, we get only 6. Minus, I'm saying again, if you do differentiation of this one, you get 6. Then you have a minus, and then if you do differentiation of this one, you get 0, because there is no x here. Because here there is no x. That means if you do differentiation of this one, you get 0. Right. So as you can see here 6 minus 0, you can write it like only 6. So for this 6 multiplied by this 5, we have what? We have 30. And then 6x minus 5 power 4. That's the answer. Now let us solve question number 2. So as you can see, this one is like similar like before. Okay. So here also you can see there is a bracket, and on top of that there is a power. And as I said before, you need to process power first. You need to do the differentiation of power first. So if you can see, when you want to do the differentiation of power, you need to bring the power first. And then power will be reduced by 1. So we have power 5, and if you reduce power 5 by 1, that means if you deduct 5, if you deduct 1 from 5, we get 4. So this is up to this one is the differentiation of the power. So that means up to this one is the differentiation of the power. Up to this one is the differentiation of the power, right? So I'm saying again, when you do differentiation of power, this power 5 will come first, right? And then you will write exactly like what you have, and from the power, from the existing power, you need to deduct 1. So we had power 5, and from that one, if you deduct 1, we get 4. We get power 4. Then you need to do differentiation of inside materials. Inside we have 2x plus 6. So you need to separate each part out. So you can see, if you do differentiation of 2x, we get only 2. And if you do differentiation of this one, since we do not have any variable along with it, the answer is 0 for this one. So we have only 2. So this 2 and this 5 we can multiply each other. We can multiply 5 with 2 and then we will get 10 multiplied by 2x plus 6 power 4. So that's the answer. Now let us move to next one, this one. So here again it's like before, we have a bracket and on top of that a power. So when you have something like that, you have to bring the power first, and power is 3, and we have this one, and from the power 3 we will deduct 1. So from the power 3 if you deduct 1, the power will become 2. So that's the differentiation of this part is the differentiation of power. That's the differentiation of power. And inside, if you do differentiation of inside material, you have 2x there. If you do differentiation of 2x, you get only 2. So now if you multiply this 2 with this 3, you get 6. So 6 multiplied by, and then again here let me write another step here so that you can get a clearer picture. Sorry, where did I get this from? So now here you can see this 2x square can be written as like, this 2x square can be written as like 4x square. This 2x whole square can be written as like 4x square. So now if you multiply this 2 with this 4 and also this 3, we get what? We get 24. And then we have x square. So 24x square. So that's the answer. Now let us move to the next one. Question number 4. Here you can see we have 6x power 1/3. So if you do differentiation, as I said before, there is a bracket here and on top of that there is a power. If you have something like that, you have to process the power first. So if you process power, what do you get? The power will, you need to write the power first. The power 1/3 you will write it first, and then from the existing powers, then from the existing power you need to deduct 1. Right? So this part is the differentiation of the power. And then we need to do differentiation of inside materials. Inside we have 6x. So you need to do differentiation of inside materials. So if you do differentiation of inside materials, you will get 6. If you do differentiation of this one, you will get 6. So you will get 6 if you do differentiation of inside material. Right. So now 1/3 minus 1. This 1/3 minus 1 is equal to minus 2 by 3. Right. So now as you can see, one more thing. The student commonly do this mistake. Okay, the students commonly do this mistake. This 6 cannot be multiplied with this 6. This 6 cannot be multiplied with this 6. And again, this 6 cannot be multiplied with this 1/3. Right? Because why? Because this 6 is not alone. This 6x is locked by this power. This 6x is not alone. This 6x is locked by this power. So that means you cannot multiply this 6 with this 6. You cannot multiply because this 6 is not alone. This 6 has a power. Over it. So you cannot just multiply. Again, you cannot multiply this 6 with this 1/3. you cannot multiply, because this 6 is not an isolated number. This 6 is not an isolated number. It has a power over it, right? So always remember, please don't do this type of mistake in exam. So now as you can see, we have a minus in the power. We have a minus in the power. As you see that the question is saying that, question is asking us to remove minus from the power. Question is saying that you cannot leave negative exponent or negative power in the answer. So you need to remove this minus from the power. And as you know that already, to remove the minus from the power, you need to move the full part. You need to move this full part to the denominator. That means if you want to remove the minus sign from the power, you need to move this one. You need to move the power along with the base. You need to move the power along with the base, and here the base is 6x. You need to move the power along with the base to the denominator, except the minus sign. Except the minus sign. So this one, that means this one we have moved it into the denominator. This one we have moved it to the denominator, and since we do not have in the numerator, we put 1 there. So it is like this 2 also is in the numerator, and this 1 will get, this 2 will get multiplied with this 1. We will have 2 on the numerator, and this one can be written as like this one. This one can be written as like this one. Why? Because this 2, let me write another step here so that you get a clearer picture. So here, this 2 will write it here. This 2 by 3 can be written as like this 2 by 3 can be written as like this. This 2 by 3 can be written as like this. And always remember, if there is a power 1/3, it can be written as cubic root. It can be written as cubic root. So that means there is a power 1/3 here. So this, for this power 1/3, we can write it like this way. We can write it like this way. Pay attention. How am I writing it? So here square. So that means inside you have a cubic root of 6x. Because of this 1/3, we got cubic root of 6x, and then on top of that, let me write another step here so that you get a clearer picture. This is you might find it a little difficult. In that case, I will request you to study at home this one, okay? So we can write it like this way. As I said before, we can write it like this way. This 6x power 2 by 3 can be written as 1/3 multiplied by 2, right? So when you have a power 1/3, for 1/3, you can put cubic root. You can put cubic root for power 1/3. For power 1/3, you can write cubic root. Okay, so that means you can write it like this way. This one can be written as this or 2, right? We can write it like this way. 6x power 1/3, on top of that another power 2, because 1/3 this power inside the bracket can get multiplied by power outside the bracket, power outside the bracket. So if you multiply 1/3 with these 2, you get 2 by 3 back, you get 2 by 3 back. So we can write it like that way. So 6x power 1/3, 6x power 1/3 can be written as like this, cubic root of 6x. So 6x power 1/3, 6x power 1/3 can be written as cubic root of 6x, and then on top of that we have a power 2. Then on top of that we have a power 2. We can write it like that way. So right. So that's the answer. That's the answer. That's the answer. So now let us solve question number 7. Question number 7. Let us solve question number 7. What we have here? So this is the function. This is the function. So we need to do differentiation of this function. So as I said before, you need to first do the differentiation of the power. So that means we have the power we have is 3 by 2. We need to write the power first, and then we will write whatever we have in hand. We will write that one, and from the power we will deduct 1. From the power we will deduct 1. So from the power we will deduct 1. Right. So then, and then after we process power, after we do the differentiation of the power, then so this is the up to this one is the differentiation of the power. We will bring the power first, and then from the power we will deduct 1. So this is for the power. So that means when we do differentiation of the power, we get this one, and then we need to do excuse me excuse me then we need to do differentiation of inside materials. So inside we have 8x minus 3. So if you do differentiation of inside materials, 8x minus 3, then you should get 8. So as you can see here we have this one, and inside we have 8x minus 3, and if you do differentiation of inside materials, we get 8. So if you do differentiation of 8x minus 3, so first you need to do differentiation of 8x. So if you do differentiation of 8x, you get 8 only. And if you do differentiation of this one, since this with this 3 we do not have any variable, so if you do differentiation of this one, you get 0. So that means if you do differentiation of 8x minus 3, you get only 8. And from this 3 by 2 minus 1, if you deduct 1 from this 3 by 2, you get half. Power half. So now as you can see we have 8 here, and then we have 3 by 2 here. So if you multiply 8 with this 3 by 2, what we will get? This 2 and this 8. That means we can apply process of cancellation between this 8 and this 2 and this 2. So if you apply process of cancellation, we get only 4 here. So 3 multiplied by 4, we get 12. 3 multiplied by 4, we get 12. I'm saying again, if you apply process of cancellation between 8 and 2, that means if you divide 8 by 2, you get 4 here. So that means this one will not have this one, and if you cancel out this with this one, we will get 4 here. So if you multiply this 4 with this 3, you get 12. Right. So like that way. So and then 12 multiplied by 8x minus 3 power half. 8x minus 3 power half. So this one we can write it like, you can keep the answer up to this. You can keep it like that. This is the final answer. But if you want to simplify further, we can write it like this way, because always remember, power half Power half means square root. Power half means square root. Power 1/3 means cubic root. Power 1/3 means cubic root. Power half means square root. Since we have this power half over 8x minus 3, so we will have square root of 8x minus 3. So 12 multiplied by square root of 8x minus 3. So that's the answer. Right. So question number 8, you can solve it at your home. It's very easy. So let's do question number 9. Let's do question number 9. So we have these one. It's similar like before. You need to process the power first. You need to process the power first. So if you do want to do differentiation of this one, you need to process power first. So we will bring the power first. That means we will write the power first, and from the power we will deduct 1. So we will deduct 1, and then we need to do differentiation of inside materials. We need to do differentiation of inside materials. So no power will be there here. So we will not have any power there because we have already done the differentiation of the power. So in this case we will do only differentiation of inside materials. So no power will be there here. Okay. Right. So no power will be there in now. So now we will do only differentiation of inside materials. So now as you can see 5/2 is there, and this one, if you deduct 1 from 5/2, we will get 3/2. We will get 3/2. And if you do differentiation of this one, we will get 3 multiplied by twice x. So that means 6x. So let me write another step here better, so that you don't get confused. So 5/2 minus 1 is like this is like this. This is like this. And if you do differentiation of this one, what we will get? We will move 3 out because this 3 is the coefficient. Because this 3 is the coefficient, of x square. So now we will do differentiation of x square. If you do differentiation of x square, we get twice x. If you do differentiation of x square, we get 2x. And then minus, if you do differentiation of 6x, we get only 6. If you do differentiation of these 2, we get 0. Right. So now what we get? 3 multiplied by 2x, we get 6x minus 6. So we get 6x minus 6, and from here we get 5 minus 2/2, that means 3/2. So that's that we get. Now as you can see here, we have 6x minus 6. We can take 6 common. Differentiation is done. Now we can simplify. So we can take 6 common here. So if you take 6 common, we will have x minus 1. Right? And then this 6 and this 5/2 can get multiplied with each other. So if you multiply this 6 with this 5/2, this 2, you can apply process of cancellation between this 2 and this 6, because 6 is in the numerator and this one is in the denominator. So 6 can be divided by these 2. So if you divide 6 by 2, this one will be out. So here we will have only 3. So this 3 multiplied by this 5, we will have 15. So we will have 15 into x minus 1 multiplied by, so we will have 15 into x minus 1 multiplied by, so this 6 and 2 cancel each other out. We will have 3 here. 3 multiplied by 5 is 15, and from here we have 6x minus 1. We have 6x minus 1 and then this one. So 15 multiplied by x minus 1 multiplied by this one, power 3 by 2. Now what we have, so we can write another step here. So this one can be written as like this 3, we can move it here. So here we will have 1. So 3 by 2, we can write it like half into 3. So as you know, I have told you that this half can be written as like, we can write another step here. We can write it like this. So we have half multiplied by 3. We can write it like 3x square minus 6x plus 2 power half, and then over bracket another power 3. So you know that already. If you have power inside the bracket, this one, and if you have power outside the bracket, this one, this power inside the bracket will get multiplied by power outside the bracket. That means we will have half multiplied by 3 again. That means we can break this one like this. Okay, so now you know that already. Power half, for power half we can write, square root. For power half we can write square root, and on top of that we have power 3. So we have power 3 here. So for power half we will get square root. For power half we will get square root, and on top of that we have a power 3. So we will have power 3 here. So that's the answer. So question number 10 is here. So it's a similar like before. First we will do the differentiation of power. Here the power is 4 by 3. We need to bring the power first. And then from the power we will deduct 1. So that's the differentiation of the power. And then we need to do differentiation of inside materials. So inside we have x cube. So if you do differentiation of x cube, we get 3x square. Why? This 3 will come, we need to write this 3 first for the power. So power, we need to do the differentiation of power first. So this 3 will come first. That means we need to write 3 first, and from the power we will remove 1. We will deduct 1. So we have 3 here. So if you reduce it by 1, we will have 2 here. So that means if you do differentiation of x cube, we will have 3x square minus, now if you have, now you have 3 here. So you have 3 here. So as you can see, this, let me write another step here. So now this 3 will be as it is, and then here you will have 2x. So that means this 3 is the coefficient. It will sit as it is. This 3 is the coefficient, it will be outside. That means we will not do differentiation of this one. We will only do differentiation of x square. So x square, if you do differentiation of x square, you will get 2x, because the power will come first. That means power you need to write first, and then the power will be reduced by 1. So we have already power 2. If you reduce it by 1, we will have only power 1. So as I said before, if you have only power 1, you don't have to write it. So we have, so that means if you do differentiation of x square, we get 2x, we get 2x. So 3 multiplied by 2x can be written, you can write it like 6x, right? So now if you do differentiation of this one, we have 6x here. If you do differentiation of this one, we get only 6. We get only 6 there, right? Now as you can see, here also 3, here 6, here 6. So here we can take 3 common. We can take 3 common. So if you take 3 common from, here, so we get x square. We get x square minus, if you take 3 common from this one, you get 2. So that means minus 2x. If you take 3 common from here, you get 2 here. You get 2 here. You get 2 here. So if you take 3 common, we will have x square minus 2x plus 2. So now as you can see, this 3 will cancel this 3. This 3 will cancel this 3, right? Because all of these are in multiplication. All of these things are in multiplication. So this 3 will cancel this 3. So we have only 4 here. So that means 4 multiplied by, we just to simplify, we have just written it like that we have written this one first and then we have written this one. Okay, just this is arrangement. It's not very necessary. You can write it like this also. 4 multiplied by, let me write another step here so it will be clear for you. So it will be like this, because this 3 and this 3 will cancel each other out. This 3 and this 3 will cancel each other out. This 3 and this 3 will cancel each other out. So we will have only 4 here. So 4 multiplied by power this one power 1/3 multiplied by x square minus twice x plus 3 2. That's the answer. That's the answer. So in other way, you can simplify it, like you can rearrange it. It's not very necessary. You can write this one first and you can write with this one with the power later. It's not very important. So now we will move to question number 13. Question number 13. Okay, we will move to question number 13. Let's solve this one. Question number 13. What we have here? We have the function we have here is 4 to the 4 divided by twice x minus 3. 4 divided by twice x minus 3. So you can see we can write this one. So I need to write like this. So we have so this is the function. This is the function. So this is the function we have. We can put a bracket there. We can put a bracket there. So as you can see, with over this bracket, over this we have in the denominator we have this twice x minus 3. in the denominator we have this twice x minus 3, and on top of this, and on top of this bracket, we do not have any power. We do not have any power on top of this bracket. So there is no power doesn't mean that there is no power. That means there is a power. There is a power which is 1. There is a power which is 1, because power 1 we don't need to write it. So but there is a power. There is a power. So that means this twice x minus 3, we have this twice x minus 3 in the denominator, and this can be contained inside a bracket, and we do not have any power over it. So this will be like twice x minus 3 power 1. Right, so power 1, if you ignore it, we will have this twice x minus 3 back. So as I said in my last class, that if you have anything in the denominator, if you have the variable in the denominator, to process it, you need to lift it up. That means you need to move it up. So if you move this one up, the power will become negative. The power will become negative. If you move this one up, the power will become negative. 4 was already in the numerator, so 4 will be as it is. 4 will be as it is. But if you move this one, if you move this one, if you lift this one up from the denominator to numerator, the power will become negative. Power will become negative. Power will become negative. Now, as I said before, this 4 is the coefficient. 4 is the coefficient, so you need to move this 4 outside. 4 is in multiplication with this one, so this 4 need to move outside. So we will move these 4 outside. So now we have this one, so we need to process this one now. Now as you can see, we have a power over a bracket. We have a power over a bracket, so you need to process the power first. You need to process the power. You need to process power first. So as you know that the rule of power says that power will come first. That means you need to write the power first. So we have in the power is minus 1. So we need to write the power first. That is minus 1. And then from the existing power, which is minus 1, we need to deduct 1. We need to deduct 1. We need to deduct 1. That means minus 1 minus 1. And then, so that means this is the, so this part is the differentiation for the power. So that means this part is for the differentiation of the power. This part is for the differentiation of the power. Now power, we have already done the differentiation of the power. So this power is we have already processed the power. That means we have already done the differentiation of the power. Now we can process inside materials. Inside we have 2x minus 3. Inside we have 2x minus 3. So as you can see, now we need to do differentiation of this one, right? So here again we have two parts. If you do differentiation of 2x, you get only 2, and this one, if you do differentiation of this one, we get 0. So that means if you do differentiation of 2x minus 3, you get only 2. You get only 2. So now you can see we get only 2 here. We get only 2 here. And now from this one we get minus 1 multiplied by this 4. We can write like minus 4. We can write minus 4. And then we have 2x minus 3. This 2x minus 3. This 2x minus 3. And on top of that we have minus 1. Minus 1. So power will be like minus 2. Power will be like minus 2. Now as you can see, this 2 is an isolated number, and also this 4 is an isolated number. All of these are in multiplication. So this 2 we can multiply this. We can multiply this 2 with this 4. With this 4. So 4 multiplied by 2 is equal to 8. So we have minus 8. 2x minus 3 power minus 2. Power minus 2. So as you can see, as the question is saying that, question is asking that you are not supposed to leave minus power or negative exponent in the answer. So as you can see that there is a negative exponent or negative power in the answer. So that means we need to process it further. That means we need to remove this negative power from the answer. We need to remove this negative power from the answer. So if you want to remove this negative power from the answer, as I said before, to remove the negative power from the answer, you need to move the power along with the base. You need to move the base along with the power to the denominator without the minus sign. So you will move full these one, we have moved full these one, full 2x minus 3 power minus 2 into the denominator, except the minus sign, except the minus sign, and then minus we will keep it in front, and 8 we can keep it over the numerator. So this is the answer, this is the answer, right? So this is the answer. Now the same problem can be solved in a new, using a new formula, division rule. Same problem we can solve it using rule of division, using rule of division of differentiation. There is a rule of division for differentiation. So now we will apply that rule, right? So another method. Now same problem we will solve it, same problem, same 4 divided by twice x minus 3, we will solve it in a new method. So what's that method is? This is called division rule of differentiation. This is called, now we will apply division rule of differentiation. So to apply division rule of differentiation, you have to first get a fraction. You have to get a fraction first, and then whatever you have in the denominator, you will bring that in the denominator. Whatever you have in the denominator, you will bring that in the denominator, and you will get a square. You will get a square. Remember, this is the formula. This is the formula for division. So, okay, this is the rule of division for differentiation. This is the rule of division for differentiation. This is, here we have 4 divided by 2x minus 3. So this is division. So we have here 4 divided by 2x minus 3. So we can apply rule of division for differentiation. So when you apply rule of division for differentiation, whatever you have in the denominator, you can just square it. That means we have 2x minus 3 in the denominator, we will square it. We will square that one. We will square that one. This is the rule. And then whatever you have in the denominator, you will write that like this. So we will put a bracket there. We will put a bracket. So whatever you have in the denominator, we have 2x minus 3. We will write the same thing in the numerator also, and then we will write d by dx. We will write d by dx of the whatever you have in the numerator. So d by dx of whatever you have in the numerator. We have 4 in the numerator, right? And then minus, and then what we will do is we will bring this 4 again here. So this 4 was in front of d by dx. This 4 was in front of d by dx. Now this 4 will go behind after minus. After this minus, this 4 will go behind d by dx. Now this in front of d by dx, 2x minus 3 will come. So pay attention. Let me explain it again. So when you have something like that, we can use division rule, because this is 4 divided by 2x minus 3. So when you have something like that, we can apply division rule of differentiation. And in such case, whatever you have in the denominator, we will square it. That means we will get a fraction first. Whatever you have in the denominator, we will just square it. So we have in the denominator twice x minus 3, so we get square of it, right? And then again, whatever you have in the denominator, you will write the same one in the numerator, and then you will write d by dx, and in front of d by dx you will write whatever you have in the numerator. Whatever you have in the numerator, you will write it in front of d by dx, and then that we will put a minus. You will put a minus, and now what we will have, this 2x minus 3, this 2x minus 3 was behind d by dx, behind this d by dx. Now this 2x minus 3 will come in front of d by dx. So after minus, after this minus, this 2x minus 3 was behind d by dx. Now this one will come in front of d by dx, and this 4 was in front of d by dx. So after minus, this 4 will come behind d by dx, behind d by dx. So it will be just, it will be, they will exchange their position. This 4 after this minus, this 2x minus 3 will come here in front of d by dx. This 2x minus 3 will come in front of this 2x minus 3 will come in front of d by dx, and this 4, this was in front of d by dx. Now this will go behind d by dx. Now this 4 will go behind d by dx after this minus. So this is the formula. This is the formula. So now what we have here. So here you can see there is no d by dx. Here you see there is no d by dx, so you don't have to do differentiation of this one. So since there is no d by dx here in the denominator, you don't need to do differentiation, or you don't need to do any processing. You just leave it like that. Here this 2x minus 3, this 2x minus 3 is behind d by dx. So that means you don't need to do whatever you have behind d by dx. Whatever you have behind d by dx, you don't need to do differentiation of that one. Since this one is behind d by dx, so it can be left as it is. You don't need to do differentiation for this one. You need to do differentiation of whatever you have in front of d by dx. That means you need to do differentiation of whatever you have in front of this d by dx. So that means whatever you need to do differentiation of whatever you have in front of this d by dx, and we have here in front of d by dx we have 4. That means you need to do differentiation of 4. But here variable is x, so that means since we do not have any x here, we will get 0. So that means if you do differentiation of this one, you get 0. You get 0. So now here you have 4. We have 4 after minus. This 4 is behind this d by dx. So that means you don't need to do differentiation of this one, because this is behind d by dx. So you don't need to have to worry about it. What do you have to do? You have to do differentiation of this one. You have to do differentiation of this one. And now if you do, there is a minus. So that means you need to do differentiation separately. First you need to do differentiation of this one. So if you do differentiation of this one, you get only 2. If you do differentiation of this 3, since it doesn't have any variable, we get 0. So that means if you do differentiation of this one, you get only 2 here, and then you got only 0 here. That means if you do differentiation of 2x, you get only 2. You get only 2. If you do differentiation of this one, you get only 0, because there is no x. So excuse me, you get only 0, right? So now as you can see here, 0 multiplied by something will always be 0, and here we got only 2. Here we get only 2. So that means 4 multiplied by 2, 4 multiplied by 2 is 8. So 4 multiplied by 2, we will have 8 here. We will have 8 here. So that means we have only minus 8 here. So that's the answer. That's the answer. So if you want to simplify, or if you want to arrange this one better, you can put the minus in front of here. Okay, so that's the answer. That's the answer. As you can see, the answer is same. Doesn't matter whatever method you apply. Here also the answer was minus 8 divided by, here the answer was in the previous method. In the previous method, the answer was 8 divided by 2x minus 3 square. When we apply division rule, still the answer is same. Still the answer is same, which is minus 8 divided by, still the answer is same, which is minus 8 divided by 2x minus 3 square. So answer will always be same. Right. So now question number 13. Question number 13, you can solve it at your home. This is same like question number 12. Oh, okay. Question number 13, I have already solved it. Okay, question number 13, I have just now solved it. So let's see what we have in question number 14. Question number 14, you solve it at your home, because this is similar like question 13. Question number 14 is similar like question number 13. Sorry, question number 13. Question number 14 is similar like question number 14 is similar like question number 13. You solve it at your home. You can either solve it using this method, or you can use rule of division of differentiation. You may use division rule also. This one you may solve it using this method, or also you can use the rule of division also for this one also. So you solve question number 14, question number 15, 16, 17 at your home. Similarly, you solve question number 18 also at your home. Okay. Question number 15, you can solve it at your home, because this one is very easy. This one is very easy. You solve it at your home. If you find any problem, you can ask me. You can ask me in our next session. I will help you to solve it. So similarly, question 16 is also easy. You solve it at your home. If you find any problem, you ask me in our next session. 19, you can solve it at your home. So similarly, you can solve all the problems. You can solve all the problems at your home, and if you find any problem, you can always ask me. Okay, you can always ask me. Remaining problems, you can solve it at your home. Remaining problems of this problem 7, remaining problems of this exercise, you solve it at your home, and if you find any problem, you can ask me over our next orbit session. Okay, so that's the end of our this lecture.